The moon feels ordinary because it has always been there. Quiet, pale, predictable. It governs our tides, steadies Earth's tilt, lights our nights, and silently shapes life in ways most people never think about. But the moon is not just decoration. It is a stabilizer, a shield, a regulator. Now imagine replacing it, not destroying it, not losing it, but swapping it instantly with another moon from somewhere else in the solar system. The result would not be a harmless visual change in the night sky. It would be a planetary experiment with consequences written into oceans, climates, coastlines, and even Earth's long-term survival. Some moons would flood the planet. Some would tear it apart slowly. Some would destabilize Earth so badly that life might not last. Let's explore what would really happen if Earth borrowed other moons. Titan, the orange giant that drowns the coasts. If Earth suddenly acquired Titan, the enormous moon of Saturn, the sky would change overnight. Titan is larger than the planet Mercury and cloaked in a thick, nitrogen-rich atmosphere. Instead of crisp white moonlight, nights would glow with a hazy amber tint, as though Earth were perpetually trapped in twilight. Visually, it would be mesmerizing. Physically, it would be catastrophic. Titan is far more massive than our moon, and that extra mass would dramatically increase its gravitational pull on Earth's oceans. High tides would surge much higher than anything coastal cities were built to withstand. Twice every day, shorelines would flood. Erosion would accelerate. Entire coastal regions would vanish under repeated tidal assault. This would not be a one-time disaster. It would be a permanent new normal. Meanwhile, Titan itself would not survive unchanged. Closer to the sun, its methane seas would begin to evaporate. Its icy crust would soften. Beneath it lies a vast subsurface ocean of water, possibly hundreds of kilometers deep, which could be exposed for the first time. For scientists, this would be revolutionary. For Titan, it would be temporary. Titan's gravity is too weak to hold onto thick atmospheres long term. Over millions of years, its gases would leak into space. What began as a glowing orange giant would slowly dry out, becoming another airless, lifeless rock. Earth would endure. Civilization likely would not. The moon that shakes the planet. If Titan feels large, Ganymede makes it look modest. Ganymede, the largest moon in the solar system, would dominate Earth's sky. Its icy surface reflects far more sunlight than our moon, turning nights unnaturally bright. Astronomers would struggle to see the stars. Darkness itself would become rare. But brightness would be the least of Earth's problems. Ganymede is roughly twice as massive as our moon. Its gravitational pull would generate global megatides, flooding coastlines and violently reshaping ocean circulation. The energy transferred into Earth's crust would be immense. Earthquakes would become more frequent. Volcanic systems could awaken worldwide. And yet, there is an irony. Ganymede would stabilize Earth's axial tilt more effectively than our current moon. Ice ages might vanish. Seasonal chaos could be reduced. Climate, over very long timescales, might become more consistent. Ganymede itself would warm. Its thick ice shell, over 100 kilometers deep, could begin to melt, forming clouds and surface oceans. Beneath it already lies a massive saltwater ocean. Given time, Ganymede could become one of the most intriguing habitable environments humans have ever encountered. But Earth would pay a violent price for that stability. The fire moon. That finally calms down. Io is a nightmare up close. It is the most volcanically active body in the solar system, constantly torn apart by gravitational forces from Jupiter and neighboring moons. Its surface is covered in lava lakes and erupting sulfur volcanoes that blast material hundreds of kilometers into space. If Io replaced Earth's moon, the night sky would glow golden. Its eruptions would be visible through backyard telescopes. The spectacle would be unlike anything humans have ever seen. Surprisingly, Io would not be Earth's worst option. Io's size and mass are similar to our moon's. Tides would increase slightly, but not catastrophically. Without Jupiter's immense gravity stretching and squeezing it, Io would cool. Its volcanoes would slowly fall silent. Over time, it would become geologically quiet, more like the moon we know today. From a planetary stability perspective, Io might actually be survivable. From an aesthetic perspective, humanity would witness a fiery moon slowly going dark. A frozen ocean, next door. Europa has fascinated scientists for decades, and for good reason. Beneath its smooth, icy crust lies a vast saltwater ocean, possibly deeper than all of Earth's oceans combined. Evidence suggests this ocean interacts with Jupiter's magnetic field, hinting at active chemistry and, potentially, life. If Europa orbited Earth, it would reflect far more sunlight than our moon. Nights would be brighter, tides would weaken slightly due to its lower mass. Over long timescales, Earth's axial tilt could become less stable, leading to stronger climate swings. But the scientific opportunity would be extraordinary. Europa would be only days away by spacecraft. Humans could walk on its surface, drill through ice, and explore an alien ocean without leaving Earth's neighborhood. For a brief window of cosmic history, Europa could become humanity's most important scientific frontier. Eventually, without Jupiter's gravitational heating, Europa's ocean would freeze. Its surface would quiet. But for a time, the solar system's most promising ocean world would sit just beyond Earth's atmosphere. Triton, the moon that moves the wrong way. Triton is strange even by cosmic standards. It orbits Neptune in the opposite direction of the planet's rotation, suggesting it was captured long ago. Its surface is among the coldest known in the solar system, yet it hosts active cryovolcanoes, eruptions of ice and gas instead of lava. If Triton replaced the moon, it would orbit Earth backward. Its mass is lower than our moon's, meaning tides would weaken significantly. Over millions of years, Earth's axial tilt would drift more wildly. Climate patterns would become unstable. Ice ages could deepen and arrive unpredictably. At first, Triton would be spectacular. Its icy surface would blaze in the night sky. Cryovolcanic plumes would shoot kilometers high. But closer to the sun, Triton's frozen nitrogen would vaporize, forming a thick atmosphere and possibly even a comet-like tail. Eventually, Triton would lose much of its ice and shrink into a quieter remnant of its former self. Earth, meanwhile, would slowly lose its long-term climate stability. The moons that end the world. Mars's moons are barely moons at all. Phobos and Deimos are tiny, irregular chunks of rock, likely captured asteroids. Replacing Earth's moon with them would plunge the planet into darkness. They would appear as faint points of light, barely distinguishable from stars. Moonlight would vanish. Ocean tides would collapse, driven almost entirely by the sun. Coastal ecosystems would fail. Marine life would be thrown into chaos. Over long timescales, Earth's axial tilt would wander freely. Seasons would become extreme. Ice ages could lock the poles at the equator. Climate stability, the foundation of civilization, would disappear. Worse still, Phobos is slowly spiraling toward Mars. If it orbited Earth, it would eventually break apart or crash into the planet. An impact of that size could rival or exceed the asteroid that ended the dinosaurs. This swap would not just disrupt life, it would likely end it. Enceladus, a bright ice world with hidden risks. Enceladus is smaller but deceptive. It reflects sunlight more efficiently than almost any object in the solar system. Its icy surface constantly erupts water vapor and ice particles into space, feeding Saturn's rings. Beneath its shell lies a warm ocean, another potential cradle for life. If Enceladus orbited Earth, nights would still be visible, though dimmer. But its low mass would cause the same fundamental problem as Mars's moons: weak tides, unstable axial tilt, and long-term climate chaos. Over time, Enceladus would warm, its ice would sublimate or melt. Oceans could appear on its surface. Scientifically, it would be fascinating. For Earth, it would still be dangerous. Why Earth's moon is almost perfect. After imagining all these scenarios, one truth becomes unavoidable. Earth's moon is not special because it is dramatic. It is special because it is balanced. It is massive enough to stabilize Earth's tilt, but not so massive that it destroys coastlines. It drives tides without overwhelming them. It lights the night without erasing the stars. It has been quiet long enough for life to evolve. Swap it with something bigger, and Earth floods. Swap it with something smaller, and Earth wobbles. Swap it with something strange, and Earth destabilizes. The moon is not just Earth's companion. It is one of the reasons we are here at all. And after seeing what the alternatives would do, it may be the most underrated object in the solar system. If you enjoyed this deep dive into what would happen if Earth swapped its moon with others across the solar system, there are plenty more cosmic waiting to be explored. If you want to keep uncovering them, like and subscribe. It really helps the channel grow, and it tells the algorithm you want more science-driven storytelling like this.